Okay, so let's jump right in. We are going to be talking about one of the most useful, honestly, one of the most powerful tools in your chemistry toolkit. It's the dilution formula. C1V1 equals C2V2. And trust me, this little equation, it's about to become your absolute best friend. So, have you ever been staring at a test? You see a question about making a solution, and your brain just kinda freezes. You know that feeling? With all the percentages and molarities and volumes, it's so easy to get tangled up. We've all been there.
But what if I told you that pretty much every single one of those problems can be cracked with one simple, beautiful formula? This is it. C1V1 equals C2V2. This is the key. This unlocks everything.
And look, I am not kidding when I say it solves them all. Let's take a look at just how versatile this thing really is.
Yeah, this is not some random formula you'll use once and then forget about. No way. You are going to see this all the time. It's a total staple on chemistry math tests, it pops up in neutralization problems, and it is the absolute backbone of any question about percent dilutions. Nailing this formula is a huge, huge win for you.
So why does it work so well? What's the secret sauce here? Well, the secret is that it's based on an idea that is so simple, so intuitive, you actually already get it. And here it is. This is the simple secret behind the whole thing. All this fancy-looking formula is really saying is that when you dilute something, you're not actually changing the amount of the chemical you have. You're just changing how much water it's swimming in. The amount of stuff you start with is the exact same amount of stuff you end with. That's it. Simple, right?
So let's properly break this down. C1 and V1. That's your before picture, your starting concentration and your starting volume. Then you have C2 and V2. That's your after picture, your final concentration and your final, and this is important, your final total volume. We're going to come back to that detail. Now here's the really cool part. This formula is super flexible. You're working with percent? Great. Working with molarity? No problem. There's just one golden rule. Whatever unit you use for concentration on the left side, you have to use the same unit on the right side. That's it. Keep your units matched up and you are good to go.
Okay, enough with the theory. The best way to really get this is to see it in action. So let's walk through a totally classic dilution problem step by step.
Here we go. Here's our problem. We've got a concentrated 25% stock solution. Our mission, should we choose to accept it, is to make 400 milliliters of a much weaker 5% solution. So the question is, how much of that strong starting stuff do we actually need to use?
All right, let's crush this. Step 1, and I mean always step 1. Write down the formula. C1V1 equals C2V2. It just focuses the mind. Step 2, we plug in what we know. Our starting concentration, C1, is 25. Our final concentration, C2, is 5, and our final volume, V2, is 400. V1 is the mystery we're solving for. So then we just do a little bit of algebra, and boom! V1 equals 80 milliliters. That's our answer. We need 80 milliliters of the stock solution.
Now, hold on. Before we move on, let's talk about the common ways people trip up here. First off, when you're using percents, just use the numbers. Use 25 and 5. You do not need to convert them to decimals like 0.25 or 0.05. Also, be really careful not to mix up your before and after numbers. And most important of all, remember that V2 is the total final volume, not how much water you added, it's the whole shebang at the end.
Okay, you ready to see just how ridiculously powerful this is? Let's do a little rapid-fire round to prove that no matter what the question is asking for, the method is always the same. So, what if the unknown is something different? Let's say we start with 50 milliliters of a 12% solution, and we add water until the final volume is 400 milliliters. What's the new concentration? What's C2?
Well, we plug the numbers into the exact same formula. C1 is 12, V1 is 50, V2 is 400, and C2 is our unknown. A quick calculation, and we find out our final concentration is 1.5%. See that? The setup is exactly the same.
Okay, let's switch it up again. Now we're using molarity. How many milliliters of a 6-molar stock solution do we need to make 300 milliliters of a 1.5 molar solution? Same question, different units.
And again, the process is identical. 6.0 times V1 equals 1.5 times 300. Solve for V1, and you get 75 milliliters. It doesn't matter what you're solving for. The formula just works.
Okay, this is the big takeaway here. Are you starting to see the pattern? I mean, really see it? It doesn't matter if you're using percent or molarity. It doesn't matter if you're solving for a volume or a concentration. The basic way you set up and solve the problem, it never, ever changes.
All right, you've watched me do it a few times now. We've walked through the whole process. Now it's your turn. Time to put this into practice and really prove to yourself that you've got this down.
Here's your problem. Go ahead and grab a piece of paper, open a calculator on your phone, whatever you need. How many milliliters of 9.0 molar stock do you need to prepare 450 milliliters of a 1.8 molar solution? Seriously, pause here and give it a shot.
Okay, you ready? Let's check how you did. You should have set it up as 9.0 times V1 equals 1.8 times 450. When you multiply the right side, you get 810. Then you just divide both sides by 9.0, and that gives you V1 equals 90 milliliters. Now for some bonus points, let's talk significant figures real quick. Notice how our starting numbers, 9.0 and 1.8, both have 2 sig figs. That means our answer should too, and 90 milliliters is perfect. How'd you do?
Look, if you got that answer, that is awesome. Seriously, that means you knew exactly which numbers to grab, you put them in the right spots in the formula, and you did the math right. You are genuinely building mastery of this concept.
And what this really means, what this proves, is that this whole process is starting to become automatic for you. When you can look at a problem like that and your brain just knows what to do without having to overthink it, you've gone beyond just memorizing something. It's becoming second nature. And that, right there, is the goal.